Hello and welcome to Live Coding with Gerph. We are continuing with our work on the utility module. Oh, excuse me. Good start, isn't it? Good start. Utility module, start GOS command. So we got that to the point last week where we were working quite well. Everything was pretty good actually. So if we have a look here, we can see. So let's just grab the repository. So here we go. This is the repository we're working with. I'll paste the link to that. Yeah, and we are at the point now where we've got it working. So I'm going to go and just check we're up to date. Git status. Nothing to commit. We've got some extra commands in there just so we can see some tests and things. And if we do pyro dev common, in fact that's the command I want to use. I don't really need all the trapping and error handling because in theory this is all working. So let's give it a whirl into GOS-C and we should find that we have a command. Things may be a little bit slower today. I'm running other things in the background. There we go, lots of debug in there. Error command. Yep, error looks okay. Run the commands. Do quit. There we go. That's a exit the environment. Yep, that seems to look okay. And it recognized that it was exiting outside of the prompt. So we came back into the prompt again. What else? We have the ammo there. So we've got ammo in the thing. So it can actually run the commands and then it returns back from the commands. And yeah, we're back at the command line again. Awesome. How cool is that? So with that done, we are now at the point of being able to say we need to convert it to 64-bit because this doesn't work 64-bit. So we just do a riscos ammo build 64 to build it 64-bit. We will see some problems. So C code will all be fine, or should all be fine. Yeah, you've got to think on this. We've got a little bit of contention on the machine right now. As I say, I'm running other things in another window, so it's a little bit overloaded. There we go. Ooh. Warning, no return function does return. Okay. That's kind of fun. What was the actual error here? Oh, read escape state is trying to return the flags. That's not going to work because that's not the interface that we have for that. So that's in os.c. Read escape state. Yeah, that's not correct for 64-bit, which is good because we can now go and fix it. However, the easiest way to fix it is to have a look in here. If we have a look in C/, all the components that I've got in the C directories in the os files, because I've always put my interfaces in os, and we look for os read escape state. I bet we've probably got, oh, well that's disappointing, isn't it? That's very disappointing. Did I not have that implemented on things like readline? Oh, readline isn't there. Readline's somewhere in the midst of the modules. So if we go into modules, riscos source, readline is in sources kernel extract, c/start. There we go. And if we have a look in here, we can see there's two pairs of them. So probably the easiest thing to do is have a look at that file there. That file. Oh, yeah, we're going to be having fun with things being slow. And not really in a position to go and stop the other things, I'm afraid. Did you actually edit that? Thank you. Yeah, that's a little bit. I know what I can do though. I can stop some other jobs. Kill that one. And that one as well. Yeah, not what else I can kill. I can kill that as well. Yeah, there we go. So that's freed up a little bit of space, I suppose. All right, so what we're looking at here. Oh, excuse me. Read C, write C, beep. Very, very technical ones, these, aren't they? Get the queue length, destination, page lines, read escape state. Here we go. So that should be near enough identical to what we had. Put that down here. Oh, it's actually a slightly different function, but the intent is exactly the same, so we can probably just lift this middle section here. No, not that bit there. Lift. Oh no, don't cut it. Right. Now, one of the things that we had here was that was a uint 32. Let's try and keep that the same. 32 state. Yeah, we may as well also have that as a uint 32 as well. And we are returning true if the escape is pressed, and false if it is not. A little bit inconsistent here, but this is actually explicitly called escape check rather than the OSY. So yeah, fine. Okay, there we are. That's now done. So let's see what we get out of that, shall we? Build it. Hello, Viscous Tech. Hopefully, if this is the last, if this is the not last thing, but this is the main one. OS generator no return function does return. Well, fair enough. I mean, generate error shouldn't generate errors, but it does. Right, and then we try to link it. We've got omain, os, prompt, env, and the CRT, and we're missing functions for generate error. So multiple definitions of generate error: env escape, env exit, and env. Oh, bother, because they're in my C library. Oh, that's irritating. Maybe my C library should try and use different names. Maybe I shouldn't use the reserved underscore name. Yeah, I'm going to have to change it so it's not using the reserved underscore name, I think. Let's do that. So where is that? That's in the env functions, isn't it? It's this one's here. So that's actually the entry point, isn't it? Is that right? So underscore env exit. Yeah, they're the actual entry points. Well, why don't we call them that then? Entry, entry, entry. And then we'll look in the entry points. Come on, see if we can type them. Header file as well, and rename them there. Which also means we'll have to update them in the ones here. So let's just update those. Entry. There we are. Entry. There we go. Yeah, that's better. Wow, good day today. We're not even getting basic words spelt properly. Another one here. One here. And it was complaining about os generate error being multiply defined. So probably means we don't. It's defined in the CRT and in os. Hang on, well, I've got generate error in there. Huh. Okay. If nadef viscous 64, we don't need it defined if we're in 64-bit. Okay. End if. There we go. So that'll get rid of that one. So build it for 64 again. See how we get on with this. Nope, not happy. Oh, that's because I didn't update them. Oh. Right, let's go and update them in the file again, because I didn't actually change them all. Replace all instances of ampersand underscore env with ampersand entry underscore env. There we go. Place those and then try again. Dead good this. Looking right, looking all right. And now why does it link? We haven't got the entry points implemented. So entry points dot s is there. Oh, this is the simple application. This is just the plain application that we've just built. That's why it's not a module yet. So 64 command. I don't know what it's called. AF64. It's called GOS. Okay, that's fair enough. So command is AF64.GOS. All right. So this should be exactly the same as we were seeing previously. Oh, that's interesting. We're not getting padding on these. Did we get padding before? That looks like that. Ooh, that might be my C library being broken. That feels embarrassing. Let me check. Because I'm not using dumb printf for this. And this is in the environment handling. So this is this stuff up here. Oh, and it says %x. Oh, yes, because yeah, that actually makes sense. It probably fails in the same way on. Yeah, no, not a big deal. Let's not worry about this. This is not a. Actually, I could, if I used dumb printf for all of these dprintf ones, it would actually come out exactly the same. No matter, we'll just leave it as it is. Hello, bang. Yeah, it's interesting. That's kind of interesting. We got a data abort. Why did we get a data abort? We went into command GOS, start supervisor. I'm not sure why that crashed. I mean, abort on data transfer address 0 probably means, well, I don't know what that means. That probably means we're crashing in the read at address 0 unknown memory. Badness, very much badness. Let's have a see then. Debug trace block. Hello. Boom. Right. What were we doing? So data was fault address 0. Maybe it is accessing 0 and we're broken there. That's probably what's going on, isn't it? It probably is trying to access address 0. Where are we? So run prompt plus 50. So if we have a look in here, the bit we're crashing on is this. We're trying to read from X1, get number 17. Oh, that's checking whether it's an error. That's checking whether it's an escape. I bet we're doing this without checking the what's it called? Without actually checking if it's not null. So this will be in the prompt code because it's in run prompt. Let's have a little bit more room for this, shall we? So run prompt. Here we are. If we got an error and the error number is okay, so we did actually check that error wasn't null, and we got 17 out of it. Let's just check what happened there. So did we call os read line? So that's the call intos read line there, returning R0 to 20. Check and branch if 0 to that address. It isn't 0, but it is 0. It is 0. Have we got another 17 check? No, we haven't. Seriously? This is... Oh, what? I mean, it's possible that my data abort trapping is broken and it's not updated the registers. That would be odd. I mean, it's possible, but it would be odd. Okay, so so what we can do for this is we can actually be even more explicit. We can go trace every instruction that's executed. And we write this to trace.text. This will be slow. This will be quite slow. Oh, getting there. Yep, slow. Because every single instruction and all of the values are being decoded into that trace file. It's going to be fun. It's going to be fun. What should we do? We just have to wait, I suppose. Of course, if I turn the debug off, it would run even faster because it's spending a lot of its time just working out what it has to do for printf. Well, we'll worry about that later, I guess. Dum-de-dum, very boring. Oh no. Oh no. I'm doing tests in another window. See whether things are working. That's impressive. Dave's just posted a thing. So Spanners has posted a link to GitHub for a ZX Spectrum Next emulator that was actually derived entirely from the VHDL sources. VHDL is the hardware description language that's used to describe how you build the controllers and FPGAs and the like in things. There we go. So we got to there. Now we type hello and we get it going. There we go. Bang. Right. That's going to just take a moment. It doesn't matter. But yeah, but generating a whole emulator from the hardware description. That's kind of cool. That's pretty neat, to be very honest. Right, let's see what we've got out of this. So if we have a look in trace.text, this will be a big file. This will be a very big file. But we can look for the exception. We'll have a look for the exception. There we go. So x1 has turned out as being 1. That is not correct. That is really not correct. Why is that? Have I implemented readline in an odd way? I mean, that's possible. Let's readline. Returning the error there. Null, or the error. Oh, hang on, let's think. No, that should be okay. I'm a little confused as to why that's even returning a 1 to there, unless there's something else going on here. So we have a look in this. Hang on, what's that? So this is the exit from Swix here. We called readline 32. Fair enough. And at this point, W0 was 0, so that's good. When we got to the end of the code and returned things, our last reference to W0, what the thing we're actually going to return. Ooh, last thing, where is W0 set? I think we probably set it close to the entry here, don't we? So there's the call. Come out of the call, we're going to do something, store the registers, check and branch if 0. So our 0 is 0, it goes to there. But what if the V was set? If V is clear, go to there. Right, yeah, okay. Otherwise, yeah, so it's in our 12 at this point. Just look for X0. Next one is there. Oh, move our 12 to X0 there, and then that returns. That's the Swix call. And then we come back to here. What's this doing? Because this looks like it's doing quite a bit of stuff. Thought all the registers. Oh, that's not the Swix call. That's kernel swy. In fact, if I look here, that's kernel swy. Right, that's not the Swix call. Then we go into this. We get back a value that is 0. And so that's left as 0. And the next time we use it is down here. At which point R0 into 20, and R0 has got a value of 1. Oh, but R0 has been set to 1 here. What's this? What's this? In fact, we're doing a bunch of things here. Check if it's 0. That's the check if it's 0. Very, very confused with this. Let me go back to os readline. So here's os readline. We do nothing special here. We come back from readline. We go back from readline into the prompt code here, os readline, and all we should be doing is just checking that is the ONM 17. No, wrong way around. This one, right, here we are. So that's what's going on there. If we scroll back over this, we've got this is the kernel swy call. This is our Swix call. This is our OS read line call. And that was the OS write end that came just before it. It's kind of fun, isn't it? Why? Pyromania, pyrodev, list config trace. Let's just have a look at the trace options because there's definitely something I want to do here. Trace points. That sets them up so I can do trace points on that. Fair enough. Spy traps, because I could trap it on calling OS read line 32. There we go. What I can do there is I can make it turn on the tracing from there onwards. Except I actually want it just before that, don't I? Bother. That's frustrating. Be nice if I had, because I haven't got these operations set up for trace points. I just want that to be a bit more friendly, don't I? So I can actually set them up. So you can say what you want it to do at each invocation. Bother. Right, so the bit I'm getting confused by is this bit here. So we come back, we've got R0 as being 0. We read another value off the stack, and that's also 0. And then we read another one, and then we go, oh, well, and then we'll set things to 1. And I'm not sure what's doing that. You know what I'm going to do? I'm going to put a tiny bit of debug in here, just to say what we are returning, because this looks error escape. If we're in simple app, then return 17 error escape. Oh, we're not returning escape though at this point, we're returning something else. Read line. Actually, we know we're returning success, so what I'm going to do is printf os read line success. Of course. Oh, there we go. There we go. I've just seen it. Oh, I'm stupid. Look, here we are. Return 1. Return null. I wonder where I pinched this function from, because that's clearly wrong. I don't know where I pinched that function from. I'll have to go looking for whether that was broken elsewhere. But it almost certainly gave me a warning as well, so I probably ignored it. Oh gosh, we have a concurrent viewers 1. We have so few people here today. Right, let's run it again without the tracing, because we know that we can actually get this going. It'll be faster. Hello. System commands are not supported. That's correct. You can't do that on. Yeah, you can't call system, as in the function system, on the 64-bit library at the moment. So yeah, clearly people are busy today. That's fine. I mean, it also makes things a little bit more difficult when you've got a change in schedule. That's worked anyway. So Oh, we should probably make sure that we actually can build it for 32-bit as well, and that it still works. Yeah, that's still working. And if we do the module as well, just to check that that's working. Yeah. Okay, they all look like they're good. So let's rename symbols to avoid problems with 64-bit clib. The underscore entry end exit and friends. I also fixed the OS readline code that was returning 1 on failure in the 64-bit case. Whoops. Okay, that's good. Push that so it's visible to people, and then we'll build it again for 64-bit this time. So build the module for 64-bit. This will now definitely fail. Hi Alan. Yeah, sorry, it's an odd day where we're doing stuff on a Saturday, I'm afraid. Yeah, here we go. So we've hit the entry points code and it's gone, hang on. Ooh, that's interesting. Trailing text L not recognized on a bracket. Apparently it doesn't understand part of this code. That's fine because that's not the code it's meant to be. What we're going to do is we're going to go and create a different file for 64-bit. So where is my entry points? Here we go. So ifec build 64 1 obj plus equals o dot entry points 64 else obj entry points. There we go. Oh, for Pete's sake. Yeah, there we go. End if. Right, so when we're building for 64-bit, we now get a different. Yeah, there we go, a different one. 64-bit gets us entry points, the one that says entry point 64. Right, so now we need to actually create those files. Duplicate this. Duplicate, please. As I did just click duplicate, didn't I? Duplicate. Huh. Little surprised that's not working. We'll just copy it manually. S/entry points S/entry points 64. Okay. So how are we going to do this? Because I'm going to need some different files for this. Print macros, proc APCS, and env numbers are going to need to be. Env numbers is okay because that's a. So those are all constants. And those all got code in. So we're going to need to have different ones for those because they need to be available in 64-bit. This is the ARC64 variant of the assembly. There we go. So let's see. Now print macros is not too bad because we can just pinch it from where we've already implemented it. So if we have a look in Pyromaniac test code ARC64 is where it is. ARC64. So we have a look in here. Here we are. We've got some extra S files in here for the actual test that we're running, but also we've got, oh no, the gas file, I want the header files. So we have print macros. This is actually a 64-bit ARC64 version of that. So I can pick that up and call that new file. Not doing it. It's not creating me new file. Something's gone weird with this. Well, what we'll do is let's manually create it then. Touch header slash print macros 64. Yeah, I'll do. Bing. There we go. Print macros 64. We also want a new. Oh, let's do it this way. Sorry. We want a header swise 64. Come over here and we can pinch swise. So what we've got here is we've got swise and swise numbers split out. So we can do that. Swise 64 here. There. And then we do get header swise numbers. That's fair enough. We can do is pinch this. Copy. And look here. Yeah, most of this is not. Oh, that's actually just the swise numbers. Oh, so actually we could just include swise. Yeah, let's do that then. There we are. And I need to do the same for macros. I'll need converting, as will proc APCS. Now macros. Do we have macros? Yeah, looks like macros has already been converted, so I can do the same with that. Macros 64. It's quite handy that we've already. So why is this happening to me? Yes, sorry. I've heard people pronounce it as swi, and I was always swy, and it's just going to stay there, I'm afraid. It's one of those things, right? So because I've already converted these to ARC64, it's all going to be a lot easier for me to try and make them work. But we don't have proc APCS handled as a 64-bit version, so I'm probably going to have to rewrite that one. It's a little frustrating, but not terrible. So if we go back to here, we can just replace this swise, becomes swise 64. Macros and then proc APCS 64 we're going to have to create. So touch proc header slash proc APCS 64. So this is going to be fun because we're going to have to create all new macros. That are 64-bit safe. I mean, this looks pretty good, doesn't it? Probably going to work. Paste. Yeah, so there's no conditionals in this, so that's going to be a bit fun. And this was complaining, actually it was complaining about this syntax, not def that. So that's a bit weird, because that's a pretty common way of expressing things with this. I'm a little bit surprised that that didn't work. So let's just see where we get to anyway, because I think that's going to fail in the same way. Yeah, it doesn't like this not def proc APCS check stack. I'm going to just comment that bit out because we don't need it in this code. It's probably also going to fail with this one, config. If not defined config, then yeah, I'll just comment that bit out and comment the check here. It'll be my Objasm to gas converter that's doing things wrong. Nope, not that window, this window. Not. Does it not like L not? Is that the problem? It might be the L not that it's not like, logical not. So that was at line so entry point 64.11 in proc APCS. line 29. Yes, it's just not liking that. If not built at hang on, that's not what it's saying there. It's got, am I using the right file? Here, line 29. Oh, that thing there. Oh, if it's defined, then I think that's just confused. So again, I'm going to just set this one to be check stack false all the time, just because we know that's going to be the state. I'm going to have a look at my objasm converter. So in case anybody was not aware, I'm going to find it in GitHub, aren't I? github.com/Gerph. I didn't want the pretty print module. Pretty print code, please. Go back from there. I want the repositories. I want objasm to gas. There we go. So this is the conversion tool that handles those operations, and it does a lot of things, a lot of things, but it doesn't handle some of them. Logical variables, operators. So I'll have to have a look into it. Just a quick look in here. Just a quick look. Just a quick look. Just a quick look. L0. We don't support L0. Okay then. That would explain why that's not supported then. Oh! L0 is pretty easy. Mod is easy. Raw is probably easy. We can probably do that. And roll probably as well. Although we might need to have a different variant. So roll 32 and a roll 64 or something. I don't know. Right. Anyway. So then now it's failing to actually compile it, to assemble it, and the reason is it doesn't know these registers. That's fine. It shouldn't, because the context is different. So register naming, IP. We don't have an IP. We don't have a static. We don't have a static base. We don't have a stack limit. We do have a frame pointer, and that's already named. I think frame pointer is already named. And we don't have an IP. No, we don't have an IP. So we actually want macros 64 here. Let's just build that again and just see whether we get anything better on this. Oh, got a missing new line in there as well. Dear me. Right, lots of problems. Yeah, because the APCS entry sequence is wrong. Now, of course, everybody knows our APCS entry sequence because it's simple. We don't do that. If we have a frame pointer offset, we should do this with a push. More than 4 registers passed, so we saw them above FP. Well, actually, that's not true. So more than 8 registers is the case for what's it called? ARC64. So, oh, is it 16? It's 16, isn't it? Sorry, it's 16 registers. In fact, if you ever get more than 16 registers, then I think we probably need to just not care. In fact, let's not care. Let's not care about that. Simple ACS, just holding the link register. Register. I'm not even sure I want to do that. I'll see what the code comes out like anyway. We'll have a see. I'm actually confused. I can't remember what a lot of these sequences look like. The best way for me to find out is to go and have a look in here, one of these functions, and see whether we've got an APCS entry sequence. I haven't written them that way. I haven't written them that way. That's really good, isn't it? Yeah, we've just got regular entries and exits. Oh, that's annoying. I don't work with it very often, and I've not got my mug with me. My compiler explorer mug is not here. One time I blooming need it, and it's not there. GOS 64 simple binary C library. There we go. Right, so we have a look down here, and we can have a look at any of these functions. We'll see what they look like. Func. Here we are. This is how you do it. This is the way you do it. That's right. Right, frame pointer is in 30 is our link register, and frame pointer is in 29. So we can actually do that in here. So did we have a register list? If we did, we do that. I don't think we should even be bothering to store any registers. Well, so there's, let's give them proper names, XFP and X. No, let's call them just like that. It's going to be way less confusing there. If we have additional registers, then we'll do the same thing, but we'll also push those registers, which we can just do like that because we've got magic that does it already. Frame pointer manipulation isn't needed. Stack check just isn't even a thing. How much local stack do we need? We can do that now. We'll just allow that, and if you don't give something that's valid, we'll not have it. Right, we remove the conditional from that because we can't make these conditional. There. Right. Again, we can't make them conditional. It doesn't matter about the config. Line up to that one. And this is the return sequence, which if we pop back over here, we can see as an LDP, and then that. And again, we don't have any APCS 64 issues with that, so we can just do that and that. There's our return. If the register list was nothing, and if the register list was something, we'd do a pull. So actually, this is more like this. Do nothing on that side and pull it on the other side. Proc like that. Get rid of that, and that just goes there. Does that make the entry sequence the same as well? Yeah, the entry sequence has the same pattern. So this is common, and then we just push the registers there. Add the stack. Was that it? That's it. All right then. Let's see if we've got anything that will assemble now. I mean, the rest of it won't, but because none of the code's correct, but we can at least know the macros are correct. Must be a floating point register. Oh well, yeah, we've given register numbers there. That's the, yeah. Well, let's actually try making the code sensible then. So APCS entry, we don't need to stack anything. Actually, we do need to stack things, don't we? we need 16. Let's give us the same sort of number of registers. Oh, and sorry, X. Let's actually use the correct register naming. Right, so go to the registers. Register 16 is where we're going to be storing this. There's 16. X0. This is going to be 17. Hang on, I'm going to have to check my register numbers. ARC64 register assignments, because I don't have my mug. Because I think 18 is important, and I'm thinking that I'm doing the wrong thing here. General purpose registers. Here we go. Reject all, please. Go away. Thank you. No, I want to. Just give me some blooming numbers that we can actually understand. Dev community, quick start, that looks like a good one. Oh, go away. Oh God, go away. That's ARC64. What? That's x86. That's not helpful. The old new thing. Way. Raymond Chen. We do like his things. This is what I wanted. Yes. So all of these are the ones that get passed through. Only up to 8 do they get passed there. Okay, so I was wrong when I said the 16 one, but I'm not using it anyway. I've just deleted that code. So yeah, those are usable locally, and then we've got 19 upwards. Okay, so let's use 19. So let's go and do that. So 19 to something or other. 19 to 24, something like that. So this one becomes 19. This one becomes 20. X 19, X 20. I could have named these registers, couldn't I? Register 3 is going to become X3, X3, X4 is 19, 20, and that was R3, wasn't it? Oh, sorry, not R3, X3. It's good fun, this, isn't it? Trying to remember what our registers are actually called. Drop us into user mode. Yeah, I want to drop into user mode. How do I do that? Actually, dropping us into user mode should be calling that the special mechanism we use to enter the user mode system. Right, let's just drop that for now because I've forgotten how you do that. Set the stat pointer up. Yeah. R2, R3. We've got to ensure that the stat size, you see, is that the stat pointer is a aligned address, you see. So the actual workspace size we need has got to be ANDed. So add x3 number 15 round workspace size to multiple of 16. Ooh. Multiple of 32. Because I'm going to want to do this one here. The stack has got to be, we can do this into R0, can't we? So add it into X0 and then just pick off those bottom bits. SP, comma, I don't know if this is even valid. I don't think you can move things into, no, I don't think you can move things into SP like that. Morph SP, comma, X naught. Right. Stack limit isn't used. Frame pointer is in X29. Frame pointer. Stack pointer is that. Stack limit not relevant. Initialize our global workspace. Here we go. This is going to be fun, isn't it? So R6 was 4, 5, 6. So 19, 20, 21. Okay. 21, X21, sorry. X2, X4. These are going to be pointers, and if they're pointers, we need them to be wider. If they need to be wider, then we need to do 8 and 16 here. Yeah. X0 now currently contains the stack pointer. Stack top, sorry. And then X2, handle the exit, call generate error, and generate error if a reset. Okay, BVC. There we go. That looks okay. Again, we're going to have to do some little bits of get CLI size. BVS. Otherwise, this is and then we call the OS byte, and these again just changing to X1s. Alright, so that's our CLI handler done. CLI size handler done. This one, frame pointer is X29. Stack pointer is at not 8, it's going to be 16 now. This should be a block really, shouldn't it? We should have a we don't have a stack limit either. So stack pointer at the top. Oh, what else? Oh, R0 should be X0 there. Again, X29 is FP. X12, this is now address 16, not 8. We've got bigger workspace. No stack limit. It's still coming in X12. I've kept it as X12 for the entry points here, just for sheer ease. We can always worry about that later. Escape entry points. Let's stack some things, and then yeah, so that's a little bit different because we need to stack all of the registers that could be corrupted, which is X0 through to X17 and X29 for that matter. And then X29 is the frame pointer, X, and that's the generate error call. All right. So I think some of these are going to fail, but I think most of that code is now EPCS 64 safe. Let's see. Might be completely broken. Register list pass failed. Cannot pass trailing text. Oh, we've got an R17 in there. R17. Yeah, it should be X17. mov high and mov ls. Well, that's not going to work. And yeah, you can't do loading directly into the SP, so we'll just have to fix that. That's fine. We may as well put it into load it into x1 and then do a mov sp x1 there, just like that. Same goes for this one, so that should fix that. And then the other bit was this mov high and mov ls, which is at line 128 and 129. Oh yeah, that's rubbish. There's a nice easy way of doing this with a ternary instruction, but I'm going to just do it easier. BLS 85 mov x0 common number 256 and then branch to 90, otherwise address 87. There we go, just do it that way. There we go. Undefined symbol R0 uses an immediate value at line 39. Yep, that should be x0. That assembled. It's almost certainly terrible code. Unrecognized entry in the symbol table. What's that? 0 to 17 and 29 x29. Local symbol caught with that name. That is not very helpful. In fact, I don't even know how that could be. Let's AF64 slash .sims x0. Right, it's not actually been generated into that file. That's frustrating. Although I could do O64 slash. Where's my entry sequences gone? Where's it built that? OZ. Oh yeah, of course. OZ64 slash entry points. Oh, that's probably why then. So it's OZ. Sorry, RM64 slash .sims. There we are. How on earth did your head not explode having to do this vague? So most of these vague error logs were created by me. So it makes it a little bit easier because it's part of the conversion process. But assembly, debugging is always a bit more fun as well, as you said. Right, so we've got some logs here that are saying no local symbols. Yeah, in this instance, so yeah, just looking at this, this unrecognized symbol table entry is part of the relocation table identification, which is all code that I wrote. I think it's Python code that goes and parses the symbol table, which is the symbol table we're looking at here. But the interesting bit here is it's actually using these things as local symbols, which I don't know why it's doing, because they shouldn't be local symbols. I didn't think they would be local symbols. APCS entry, unless they've been assigned to something. Possible. So this is my new APCS entry code I've got here. So it's going to be one of these. Assign it a symbol with this, blah blah blah. Do those pushes. Maybe that's what's wrong. Maybe it's the pushing that's not getting it right. I don't know what we'll try and do it with. So if we, I don't want that file, I want this one. Just get it to assemble it again. We should be able to find out what it's actually doing. Oh, how do we find out what it's actually doing? Miscos 64 objasm help. How do we do that? And these errors do need to be a lot more verbose. Maybe I can make it more verbose then. Let's try that. Copy, paste. Let's just put verbose on and see what we get. We get an error. What? That works, but if I turn on verbose, oh dear, I think that must be broken. What is it? Unrecognized parameter minus v. Apparently, I've broken it. That's not very nice, is it? Miscos shell. Let's go into here and start doing some debugging. Woo! Yeah, so same command we had. That one there. That's the one that worked. We put minus v in there. It goes on recognized parameter. So bash minus x. Let's see if we can decode what's going wrong with this. I need to. Do I need to just do debug equals true? Is that all I need? Let's try this one. Oops. I've forgotten how you do it. There's definitely a switch you set. Confused now. How do I transform? RO64 CLI transform. No. Works fine. Oh, to heck with it. Let's just have a look at the source code. Which Miscos 64 objasm. Oh, yeah, just appending it to the command line isn't going to help. Maybe I haven't used this very often. It's unwritable. RO64 debug, that's what we need to set. Alright, let's do that then. Env, sorry. Unrecognized parameter objasm. Oh, because I put objasm 64 on the end of it. Oh, which as well. Which is not correct. Get rid of that. So I left a random thing on the end of it. Now it's telling me it's not doing it. If quick. I'm very, very confused now. Turn on debug. Right, go back and edit the file then. This is where it launches into CLI transform. I can do that. CLI transform XML. So what I can do is do that. Miscos CLI transform. Put that in there. Still not giving me any debug in it. Oh, I'm very, very confused. Right, the important bit is verbose. Maybe we should have a debug option that turns the debug on. That would be a really useful idea, wouldn't it? Stupid person. Optimism gas. Da, 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 da. Oh, you know what I'm going to do? I'm going to be lazy. Copy to here. Edit it. Debug equals true. Ha. Now, run the Optimism command. Oh no, from the command directory. Still no debug coming out. If debug is true, then we turn this debug on. Is there actually no debug in this code? Is that what the problem is? There's no debug in this code. Well, that would explain that. That's very unhelpful. I think I may have to fix that. Debug running I'm probably need to do that after there. Right. There we go. Right. So that's the command that we're actually running. I don't want you to do automatic assembly. I just want you to go and generate me the file. So if we do this, we can just see int.64.gas. Like that, please. Undefined option. Oh, it's lost the quotes around that. Just do that there. Can't read input, no such file directory. Do that then. It's got the wrong. Thank you. All right. That was painful, wasn't it? Entry.64.gas. Whey! X17. Entry list is that. Dot set entry list. Is that my? Is that a variable I've set? I think that's a variable I've set, isn't it? Are we all still here? We're still streaming all right? Yeah, looks like we are. Okay, tell me what happened there. So something about that it doesn't like. Okay. I may just have to do something a bit more clever with that. Oh, let's see, because this is all our code anyway. I may have to update the parser to ignore local symbol names that are odd. So entry list, was it? What was it called? What was the variable called? Forgotten already. Entry. Oh, so X17. There we go. X17 is entry reg list, which is possibly in this one. Nope. In macros, 64, sorry. I don't know where it is. Grep 4, and that in s/star, header/star. It's in macros 64. Entry list. On entry, set it to that. So that we can use it on exit. That makes sense. Oh, I don't see an easy way of getting around that, except by forcibly preserving all the registers by hand. That's annoying. Okay, let's just do that then, just for the heck of it. We can't do it that way, so we'll do it manually. It's in entry, wasn't it? So it's the entry code, so it's in entry. Whenever we use space entry, which is this one here, no, this one, it's that function there. That's the one we want to get rid of. Actually, it's wrong as well, because X29 we don't want to push in any case. Does that fix it? That would be a no, not that. So, as you may have noticed, working with ARC64 is a pain in the behind. Working with assembly specifically is a pain in the behind. So don't do it. If you remove it from the problem goes away, which is quite a handy thing to think about. All right, so there we go. I just removed the register I didn't need, and all went well. I now have a module. Do I have a module that works? I have no idea. Load module OM64 / utility module C, FFA, and then command GOS C. Let's have a C. Nope. And the reason that it's probably failed is because we've got garbage being passed through. So if you remember when I was making the changes up here, I went, oh yes, those need to be bigger because they're different size structures. That's a pointer, so it's got to have 8 bytes rather than 4 bytes. But that was not propagated into the header file that defines it. If we have a look in the header file for globals here, not them, these things are now different. So CLI size actually could be 32 bits. It actually is 32 bits there. Should we swap that around? So that's a pointer, that's a pointer. Because I could make that int 64. There's really no reason for it to be int 64. It really should be int 32. Int 32t, that's a pointer. So let me go and fix up this code. So that's at 0, that's at 8, and this is at 12. So stack top number 16 wants to become at 12 there. There we go. Right. And that will just be exactly the same structures, I think. I need to rebuild it again. Oh, in fact, we're probably going to have to rebuild all of the code because we've changed the header file. Yeah, let's just clean it and then rebuild it all just to make sure that will work. This will take a moment or two, and whilst we're doing that, I'll go and set off my other job in the other window doing things because it's been sitting there waiting for me for a while. What should we run? Tests on. We'll run tests on tracing, shall we? See whether that works. And in another window, I am trying to basically run a number of tests and check whether things are working, so that I can go and investigate later. Oh, it's quite finished. I'll show people that once we're at that point. If I actually get a failure on that, I'll be able to show you it because it's not very interesting when everything's working fine. Right, here we go. We're coming into the code. We've read things, got to environment, and we failed. Not enough space in buffer. CLI workspace was 0. Global workspace is that. That's kind of fun, isn't it? Why does it think that we've got the wrong values for this? And then we get invalid length passed there, and it nicely, I mean, notice it's all actually exiting nice and cleanly here. We're not crashing or anything. It's got valid values, but we're actually coming out of all odd places. That was stored in there. So we called get workspace, right? What did we actually print out? What did we print out at the top? We called get workspace size 440. CLI size 128. Don't know why that's 128, but it is. Total workspace size is that. So it's actually calculated a number that looks sensible. That doesn't look unreasonable. Yeah, because the stack is what, 1024? Actually, probably stack needs to be a bit bigger, doesn't it? On 64-bit, you probably want a bit more stack. Should we give it a bit more? 4096. Yeah, we'll give it a bit more stack. Just actually, it's not going to do very much more. 248. It's good enough. All right, stack size 2048. That's where we've got the thing that we've got a stack pointer. So it prints those out and says this is where your stack pointer is. We then store the values. X0 was the stack pointer. Still that stack pointer there, yeah. CLI size is an X5. CLI size is an X5. Ooh, X5 has moved. No, these are 4, 5, 20. 20 is the CLI size. And the other one will be 21. 21, 20. I didn't update those. Oh, I've got a reference wrong here. 21 points to the CLI buffer. X21. Yeah, there we go. Again, this is why we don't do very much in there. Oh, sorry, my other runs have decided that they were going to do a whole load of extra work, and I got confused as to what exactly it was doing. Let me just do a command in the background of that. Just give me a second. I'm just. Oh. Frustratingly, all my tests keep passing. I'm a bit confused as to what I need to run now. Oh, let's just try something complicated, shall we? I don't know what's complicated. Back to real work. Our session. Sorry, I shouldn't get distracted by other things. Really shouldn't, should I? Oh, it's crashing. Excellent. Oh, it's probably crashing because I haven't got packages installed. That's interesting. It's printed out a 0 there. Why did it print out a 0? And then it came back. Whoa, bang! That was not a good position to be in. Shall we have a look at that one? Hang on, just give me a second. Yeah, there we go. You get on with that and see whether those tests work, and then we'll see what we've got here. Right, so we did a crash. We did a bad crash here, didn't we? So what we'll do is we'll run it again, but this time we'll do debug, boot debug trace block. We'll just do a trace block and we'll see what we actually got in the failure case. 2.2 trace. And we're going to need to kill this when it goes bad, because it's going to go bad. So that's interesting, because it prints out this 0 string as if it's not read the command prompt properly. Hello. Or maybe it's not been calling it with the right function. So, hello, bang, all right. Right, now we may be able to have a look at the trace file and see what we've got in there. Let's have a look at the very top, because there's going to be multiple exception reports in this. So, what did we do? We got an exception, fault address 0, read, fault status 0. Read line, this, in dumb printf. Yeah. Possible my dumb printf is too dumb. It's possible. We called strlen, and I'm guessing that what's x0? X0 does not look like a good pointer. That does not look like a good pointer to me. Oh, we're meant to be reading from x1, sorry. Oh, it is also not a good pointer. And that's come out from here, which is part of what looks like, I'm presuming that's dumb, can't be dumb printf, can it? It could be. It could be in dumb printf here. Does this mean we're passing in values wrongly? I don't know. Oh. What did we actually, we didn't, what did we get out here? So we came through here, we did this, print. So all of this printing code is working fine. It's when we get to here, we end up with an oddity. And oddly enough, that came out with a bad string. Then we printed out read line it, and it's when it tried printing out the string that it crashed, which is kind of what it's telling us here. Which possibly means we've got the wrong pointer in there. What did we do in dumb printf? I did write this very quickly, didn't I? So here's a string. We tried to read a va arg, which is the pointer, and we call strlen on it. That's pretty simple. I mean, it's also possible that the actual string that was returned, the pointer that's returned, is garbage. Let's see where we're calling it from. So this is we're calling it from the prompt code, which says print line global to CLI. Maybe global to CLI is garbage. That's also possible. Yeah, that's also possible. So maybe our read line is broken. Maybe that's what the actual issue is. We're not reading a line. Let's have a look at our implementation. If we're in 64-bit, we call readline 32. We write to the line. The length is the length we gave. And then we mark the line as being read, the extent as being terminated by 0. And we return null to say we were successful. That's pretty simple, really. That really doesn't say that we've got anything odd in there, I don't think. Okay. So I think the readline code is actually returning just fine. I think that's not a problem. And then the next thing we do is this. So since it will have read to the right place, I presume it's this printf that's gone silly. Am I not using it right? VARGs const char star, and then get a drill of it. I think that's right. Anybody remember this, Dog? I mean, it was working, certainly. Hang on. I'm wondering if this is including studarg from riscos, and that's what's causing it to get unhappy. I'm wondering if that's the case, because that would be bad. Is that? Maybe I can check. Maybe I can check. Right. When we build this, so riscos amu, there we go. Build it. It may be time for a break in a minute or two. There we go. So, interesting things here. We've got include the C colon path, which means that we're including all the C files in there, which I'm not sure is going to be correct. In fact, I'm relatively confident it's not. So what I'm going to do is, instead of doing that, minus E, and then redirect the output to dpf.txt, done printf. Right, let's have a look at dpf then. dpf.txt. Right, so what studarg are we using? That looks like the right studarg. Yeah, that looks okay to me. Well, that's a surprise. I was not expecting that. I was expecting it to be the problem that I was thinking of. Oh, excuse me. So this is the code. So you can see here, it's calling built-in VARG into args for a const char star, and then we're calling os write 0, directly calling os write 0 on it. So that should be okay, I thought. I hoped. but the Strullen is definitely crashing. Definitely crashing. Okay, I'm going to go and take a break and have a little drink, and then we'll come back and we'll have another think on this. What day is it? Yes, it's Saturday. Yeah. Remember when I said that it would be happening on Saturday? I'll reduce the rescue. Yeah. Well, there'll be a cup of tea today, but oh, I've got tea left actually. Yeah, I need to go to the loo anyway. I wasn't listening. That sounds like me most of the time when I hear things from Talia. She tells me things like, "No, I wasn't listening to that." I'm terrible. It's not so much I wasn't listening. I end up just going and it not sticking. Oh. Right. So I'm not sure why this is broken. I'm going to have a look at it, but I'm going to have to take a break first because my head is also going, I'm sore. So she is always listening, yes. So in the meantime, you see, just as a slight aside, I've got Claude looking at trying to refactor parts of Pyromaniac. It's just come up with quite amusing statements. This is a harder one. It might take another minute. It's really been thinking on this. It's having great difficulty doing the Python 3 conversion for the JPEG handling code that uses PIL, Python image library. This is a conversation compaction about 8 or something. Oh, here we go. Let's run the failing test as the output. It's quite fascinating watching it doing its work. Unfortunately, this stuff does take a while, hence why I was running it in the background or just leaving it to get on with stuff. It's going to be fun seeing it work through this, but it's not getting very far at the moment. I'm going to have to go and have a think on this problem and see what's going wrong with it. It's a bit weird. I'm all confused. I wonder if I should. No, I shouldn't. Right, okay, let's grab a drink and then we'll come back. All right, see you all in a bit. 10 minutes or so. Right, back now. Excuse me. Quite tired. Okay, fine. So, let's see what we're trying to do here. So, what we got as our crash was as if this S value is coming back as garbage, which is odd, as I say. Where's my trace file? It's over here. Move the two closer together, shall we? Move them over here. There's DPF. Right. What we're getting here is a date of abort, fault address 0, and we called strlen, and R1 was 0. Is that correct? No, R1 is not 0. R1 is that number. So what are we actually getting here? Why are we actually crashing? PC is 97C, 7C, 7C, 7C. That's that one there. Which, even if it's that one that's wrong, that's still not faulting it. Maybe my exception report is coming out wrongly. Maybe that's what's wrong with that. Maybe we're not updating it. It's quite possible that that's what we're doing wrong. Either way, this is definitely dying in an odd way. Let's try turning the debug off and then doing full trace. No, except if I turn the debug off, I don't get a printf. Yeah. I'll turn off the debug in environment because we don't need it in here. We know the environment's kind of working. And is there anything else we can turn off? Probably not, just those two. So we turn that off, build it. Right, built. Good. And then, yeah, we're gonna have to run it with full tracing. Yeah, full tracing. This will be slow. This will be very, very slow. Oh, not actually that terrible. Oh, because that was all early init stuff. It hadn't booted then. By doing boot debug, it means that only as we start the system up do we actually turn the debugging on. And that probably means that we're actually printing out something. So it's failed to print out the star. I don't know why that is. But let's try. Oh no. It was trying to do things. There we go. Hello. And then we crash. Right. Stop. Kill it. Now let's look at the trace file. Right. And find the exception. Here's our exception. Right. What did we do? So yes, this is definitely dying here. The fault address is clearly garbage. Okay, so that's good to know. This address is the one that's failing it, which is 6C, 6C, 6F. Low. So the low part of hello. Interesting. odd, isn't it? Yeah, as if it's passed the wrong thing in there. Why it's done that? Yeah, my head is tired. Very, very tired. Right. So that's the right end where we print out the previous string, which was the what's it called? Nope, brain is gone there. That's quite impressive, isn't it? Red line greater than, that's what we print out there. And then this bit here is where we're trying to, that's the right end call. Return values, blah, 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 blah. Look for a percent. We got an S. So there was an I and then there was an S. No, is it an I? No. Is it an S? Yes. If so, test if bit is set. No, test if bit is not 0. It's not 0. It's set then, isn't it? Add on 8. Basically, that's applying rounding to the particular expression. And so saying this is the thing what we're trying to get is that R0 is the address. To B58 read the word at that address. 20. Sign extend to word. So this is all the macro that's doing that work. And it definitely works in my C library because that's essentially the same code as we've got in the C library. The const jar star reader. Isn't it? Is it? Or is it something else? Let's have a look. So if we have a look in the IO printf routine, vprintf here, yeah. So we included stdarg here, yeah. And if we look for %s, so the s handler here, const char star equals va args const char star. Pretty much exactly the same thing. I have an idea what this is. I have an idea what this is. This could be stack corruption that's actually happening. But if it is, then why would we be getting a garbage? Oh, we could be getting a garbage value because something else has overwritten it. That's possible. That's quite possible. So if we have a look in Swix, in Swix there, Swix calls. All of these are, yeah, they're uint 32s. So they're not pointers. They're not 64-bit values. We're only ever updating them as 32-bit values from kernel SWI. Because at the moment we don't support anything larger. But if part of our code in here uses, that's a possibility. That's an int, which could be a uint 32. Int 32. Let's just do that. So the same thing could be true elsewhere. Let's have a look for any other uses in here. So uint pointer should be probably a uint 30. It's fine, that one though. Yeah, fine. Uint 32s. These need to be kernel swy regs, really, but that's possibly what's gone wrong here. I mean, I'm not convinced. Really not convinced. Rebuild it, and then we'll give it another go. Do you want to do it with full debug? Yeah, let's do it with full debug, because then we can actually see what's gone wrong when it does go wrong. Could take a little while, this. Very tedious. Yeah, okay, we've got our, still giving us that funny 0 there. It's rather weird because I thought we just called getEnd on that. I need to have a look. And this is hello we type here. And we've got a crash again. Go around. And we're going to have a look at the log again. Which, if we see in here, looks exactly the same. Yeah, exactly the same there. Read line. Right, here's our ROS read line function. I mean, it's not like it's particularly complicated, but it's definitely doing a whole bunch of mess in this. Oh yeah, that's pretty horrible stuff there. That's because it's the Swix handler, isn't it? It's doing all that. It's nasty. I could probably code it in assembler, but it's still very nasty. Right, so the values we got back are 0, 0, and then put them in there. 0, 32, 80, that's the range of characters. And that's that one. The range of characters only goes up to 80. That's odd. Maybe that's not right either. Okay. I'm a little bit surprised that those values are coming back from 0, but and we return back from there and we go into the dumb printf routine. So that's what R0 is, that's the format string. And then the next value is the string value, which is this value at 71E2C. That's the actual address that we're going to be printing. So if I look for that back here, store byte at 72A plus 5. But the address of this is 2C. Why has R19 got an odd? That's not got an aligned address, which I would expect it to be, because this is a read line call. So R19 here is one from the previous block. what's the code look like again? Read line. It's passed in from line, which goes into. Maybe we need to look at this a different way. Read varval here is trying to read the variable value, as we've discussed. These are interesting. So they're ints. They should probably int 32s. Because we're going to be returning back into int 32s there. So let's change that and make those there, because that maybe this read varval is also failing because of us failing to set the correct value, not corrupt the data and things. Maybe there's something else going on there. What else do we do in here? Ampersand size goes into there. Yeah. Let's have a try at that. I mean, this will break now when we build it, I think, because the types are wrong. This was not quite the easy demonstration of, oh, this will just work, that I was expecting it to be. Because I assumed, I hoped, that putting the 64-bit headers assembly in there would just work. I didn't think there would be too much in the actual interpreter that would actually, or processor that would actually go wrong. But since we're failing on printf, we're failing pretty much everywhere. Now, I really didn't want to have to drag this into a 4th week. I mean, because it's working in 32-bit just fine. So that's built okay, and didn't have any errors in other places that we need to worry about. So let's run it again. Dum-de-dum-de-dum. Still getting us that. All right, what do we actually do in the prompt? Come on, let's have a look. So print command prompt here. That's where we print out those messages. And then we call oswriten on prompt, which contains either the value from global CLI, which is the value we read the value variable into, or if there was an error, which it didn't print out that there was an error. It didn't print out there was an error, did it? Why didn't it print out that there was an error? I wrote dev common command show CLI $prompt. Is it set? Yeah, it is set to a star, but it didn't read that. Assert global. I'm wondering if this is actually like global to CLI. Equals global. As a void star. And also print out the CLI size. There, since this is working. Yeah, okay. Build it. I could have just implicit declaration of assert. Okay, fine. Let's just here we go. Wasn't that star coming out properly when I did it at the regular command line? So if I build it here, do we get the star coming out properly then? I mean, it'd be more sensible for us to test it there than to test it in the module environment. Yeah, there we go. Try that. I'm a little confused at that one. Oh, of course, it's not the same thing. It's they're not. At the, well, they are at the start, aren't they? H. CLI should be the same as global, but it's not. Wow, I'm jumping through files here. I don't want any of those. Which one do I actually want? I want the prompt, yes. In fact, it's printing out the damn things. So global workspace, and oh, of course they're not the same thing. Of course they're not the same thing. It's ampersand. Yep, brain's finally dying. CLI workspace 1024. CLI size 1024. So workspace that. Assertion deep at print command prompt, which failed. Yes, that's understandable. So let me just kill that because that is not true. Rebuild it and start again. See you later, Alan. I'm going to have to take a break very shortly, and maybe we'll come back to it next week. Or I may have a play with it on my own. I'm not sure. It's not being quite as tractable as I'd wanted it to be. There. So in this version, the not module version, it's working fine, printing out the star and decoding it properly. But when we do this in the module, so build the module version, we get a failure. It doesn't print out the star, which is fun, isn't it? 64, not that one, that one. And we don't want the tracing in there because I just want to see the same sort of values. Yeah, so there we've now got slightly different things. CLI workspace is coming out differently, which is interesting in the first instance. And we've also got those two have come out in different, there's different as the same value. So if we look here and look here, you know, that does imply that I've used the wrong registers. Workspace size is come back from there. Okay. Get CLI size to come there in R20. That's where we work them out. That's where we claim some workspace, and then the value goes into R2. Global workspace is in R2. R3 has got the total workspace size, so that's the end of that block. Clear off 15, and that's the top of our stack frame. So we just lower it down just below the end. We then clear the frame pointer, report what the stack was. R4, that's not correct. That is 19. There we go. Right. So when we were trying to access the, there's probably all sorts of other things going on here. Kill that. Kill that. 4 minutes well. Kill 2 as well. Out of the way, thank you. Right. So now we'll build it. The problem there was that we were setting up our CLI buffer as the same as our global workspace. When we read variables and when we read the readline string, we overwrote part of that buffer, which was bad, obviously. So now we should be able to run it. We still may get problems. There we go. Those values are coming out as different now. That's much better. Still not sure why this size is coming out as bigger, but it's one of those things. No, it's not just that. It's that one that's coming out bigger, isn't it? CLI size, which is an odd one. Hello. Nope, still crashing. But is it crashing in a different way? Lots of logging here. There we go. This is where we ran it. See, now got hello, and then it crashes somewhere else. That stack pointer doesn't look very good, does it? That stack pointer may not be the best. Oops. Yeah, that looks like a text string, doesn't it? There's something space. 6E, I don't know what 6E is. 14th character alphabet. 6F, 15th character. Don't know. Right, either way, that is not a good situation to be in. But it's also interesting that that's what came out. So probably it means that our error handler is broken. R12, the error handler. Hang on. R0 is the global workspace pointer. R0 is the global workspace pointer. That was a cut and paste error on my part, wasn't it? Oh, come on. Any way that we can make this entry sequence and exit sequence cleaner, so it's not having all of these oddities of the change environment handlers, would be wonderful. There we go, built it. Now let's go and run it. And I started doing that, but I've largely tried and kept everything the same. Error, hello not found, and then back into this code again. Quit. Quit use, return to parent. Whoa! Hi Andrew. Yeah, it's Saturday this week. I did post to people. There's only so much I can do to remind people, I'm afraid. Do quit. Quit. Exit handler's called. What are the things we test? I can't run AMU because it's actually, I can try running it. I mean, it's going to say, nope, 32 bits not executable in this system. Yeah. I would need a 32-bit executable. Either way, though, this is actually working. Hello. There we go. If I now go and turn off the debug in here even, we should now have, debug off. Quit, please, and then we'll rebuild it. Andrew says, it's more I didn't realise it was Saturday. I didn't know what day of week it was on. Yeah, that is a worse problem. Right, anyway. So, utility module in C with a star GOS. Hello. Error. Echo hello. Yes, does things. I could do the 64-bit binary in here so we can actually see things. What should we grab? External ports PIC-OC. Yeah, we can just use that. Copy that to here and then run it so we can actually go. So see if we can actually get this right. We are currently in new utility module. We can generate errors. Error hello in 64-bit. Just make sure. Does it say that? It doesn't actually say it on that. I did want to update this message to say it was 64-bit, but I haven't got around to it. I just put it somewhere else. Yes. So now I want to run PIC-OC. So this is starting an application, going to interactive mode. Yeah, there we go. In fact, that worked because it exited. It exited just fine. Printf in PIC-OC. There we go. So that's that. Then we exit from there, and we're now back at the command line in the utility module, which we can do help and all of that stuff. Was that painful or what? Yep, all done. 64-bit now. Add header and S. That was exceptionally painful. So yes, you missed the conversion there. It was very painful. There was a lot of little things that were wrong, and I had to add all the headers as well. All these headers needed to be converted. Some of them had already been done, but proc ABCS hadn't. But yeah, that's now working. Let's just confirm that we can still build it for 32-bit as well. That's the test program, and that's the module. Common. Not that one. That one, yep. 32-bit command line prompt. Hello. There we go, that's working as well. Okay, we are happy. I think there are still things wrong with it, but it appears to be running. Maybe not perfectly, maybe not even completely correctly, but it is running, which is what matters at the moment. Excuse me, and we can debug some more later. That will be a fun process to do. So yes, we've now done that. Commit -a. Yeah, there we go. And update the 64-bit. No, update the module to build as 64-bit with 64-bit entry points. Assembly in ARC64. That's pretty much it, really, isn't it? This was a little painful because the registers were not remapped sanely in the first hour of work. Yeah, and that was my biggest problem, was that I missed the fact that I'd not remapped some of the registers the correct way, which really does like frustrate. But now working, which is cool. Right, so I've done that, we built it. We really want to go and copy these to RM32, module C to there. not there, no. To projects, RO viscos 64 status, IM32. And the same goes for the 64-bit version as well. And then we can update the status pages. What we got here? We got anything updated? No. Oh look, there we are. We have two new modules. Add IM32, IM64. Add. That's not right. Add. And what else? Yeah, we just need to update the actual text, don't we? So, edit the sources, status, utility module. 64-bit is now functional. And if we have a look at utility module in the features, we have now tested all of these. All tested and tested. Haven't implemented the memory or the reset handler, but I don't actually think they're needed. I don't think they're needed. I'll leave them there, but I'm pretty sure they're not. So that is now done. Move that out of the way. Status. Update the utility module to confirm that it is functional. In ARC64 as well. Viscos 64 as well, I suppose more correct, isn't it? It's not just ARC64. And the new modules added to the test suite. Oh. So, if we have a look over here and give it a moment or two, we should now find that it is bumped up from internals to functional. Hey, look at that! Functionality 100%, and we're just missing the little bits here of these, which I'm not sure we even need, which makes us a little bit further along on our process here. 83% we're up to now on here, it says. I've got to do CLIV, which is pretty much, you need to do a lot of work on that one. Pretty easy. Buffer manager is a pain because it's, I don't have the vector handling done yet. OS commands, I think that's similar. Read line, similar. Video TTX, yep, same problem. All the same problems with these, and I haven't even started an OS pointer. So we're nearly done, nearly done on these, which is all pretty neat, really. Yeah, so we're looking quite good with that, I think. I'm going to call it a day there, I think, and we can probably have a look at, I don't know what we'll look at next week. What would be a good idea? I'm not really sure. I think because when we looked over here, we've got CLIV is a pretty awkward one. OS pointer, just to stub it, probably isn't too bad. OS commands, I think we're nearly done on that. There's just some of the configuration ones that are needed. I need to have a look into where we're up to on that. Module commands is completed though, that's good. Yeah, so it's functional, sorry, we only go as far as functional with this. Yeah, so there's a number there that are definitely moving along. And then we've got obviously phase 2, which has a few more things in it that we can start looking at, because there's a lot in here that needs expanding. Evaluate expression is nearly complete. Now I've got that pretty much working. Block devices, Chris managed to get to the point where the main block devices module was compilable. I don't think we actually got it to be executable. I know it was working, but so that I just need to revisit where we're up to with that. Still haven't had any word really from Steve Revel. So Andrew was asking, when you say you don't have vector stuff done, do you mean in Pyro to test or in terms of vector support in the 64-bit kernel? So I'm trying to get things working in Pyro first, and I haven't yet decided on how exactly we should handle vectors. So vectors, when you just go, the vector's gone by and you're just passing it on, is fine. But when you claim it, and when you claim it, it's no, I haven't got claims working, because when you claim, you pull the PC off the stack. But if you just pull the PC off the stack, then it's a horrible interface, really. And I was trying to avoid having it exactly the same. It also it means it, because if you want to handle chaining the vectors, which is the thing that Piers was asking about on the forums earlier. If you want to do that, you need to preserve our 10, 11, and 12, I think, and then pass it on as if you were going to be returning, and leave the stack somewhere else. And it's a mess. And Pyro doesn't support that yet. So there's a number of bits there that are really messy and don't really fit into a good way of working just yet. So I've got some bits to do there. Yeah, so I've got to go and work that to make it a bit better. I just haven't decided on the way that's going to work yet. We'll get to it, but not got there yet. Otherwise, yeah, there's a number of modules here that just need rebuilding. Like freeway and freeway hosts are just C codes. They just need building and making sure they work. Ooh, I got a crash. That's good. That's interestingly broken. Yeah, so there's some bits there that need doing. I'm not sure what else I could have a look at. Sprite extend is going to be quite fun, I know. I need to expand that out as well. Yeah, so there's some bits and pieces I think they're going to be fun to do. I've got to work those out, but I've not got there yet. Yeah, none of these kernel bits as well. Kernel mode might be interesting. Trying to handle the numbered modes, sprite modes, mode specifiers, mode selectors, all which are a lot of extra work, and things like getting the kernel vector handling working is a bit of work as well. I don't know what I want to do next week. I'm going to have to see what works. It's entirely possible that next week I might make it a sort of, I don't know if I want to do a Q&A or something like that. It might be nice to sort of do something like that for people, but we'll be back on Sunday anyway, rather than Saturday. Yeah. So yes, that's where we're at with that. I've just said to push that. Did I push the changes here? I did. That's fine. So we've got that all pushed to the repository as well. So that's all up there. But pretty much, I think that finishes the utility module. I suspect I know there are some things that aren't right about it. We can always come back yet. Come back to it later. I did say, however, I would show you the other bits that I've been working on, or rather have been worked on whilst I was doing stuff. So here we go. This is some of the RISC-OS Pyromaniac tests. This is tests for modules. So this is look at that one. That's a module crash that is reported. That's actually not failing in a bad way. In fact, all of these are actually working okay. They're just reporting slightly different error messages. That's frustrating. So this is the Python 3 version. So Python 3 pyro.py does not crash. Command GOS. Give us a command line. Oh, that crashes. Oh, that's cool. Oh, I love that. Kill. That's only on when I run it with input. That's quite fun. So if I run that with dev null, does that still crash? Oops, still crashes. No, that's not crashing, that's failing in a different way. It's part of the input stream handling that's going wrong, isn't it? So this is a whole load of things that just need handling differently, and we haven't dealt with yet. That's kind of fun though. Not quite sure what the best way is to deal with that. Oh, I wonder if I can do echo hello pipe to GOS there. Does that do it? And give us an error? No, that doesn't do it either. Gives us a different error. Oh, that's disappointing. I'm going to have to look into that. But what I've been doing is I've been trying to get Claude to do this stuff for me. So it's done a lot of the work that I've needed to do. I can't really show you very much here, but there's a... Nope, I've dragged the wrong thing. Oh, this is going to get confused now. So we've got lots of bits where it's going and changing stuff, making fixes and things, and it just gets on and does the job largely. And the way that I've been doing it is I got it to generate me a plan and to work out what it wanted to do, and I made a couple of tweaks to it and just said do this first and make this happen, and it seemed to be quite happy with it. And as I say, a lot of the bits that are broken are stuff that's not working properly because of the way that the system handles tests. When it runs the tests, it runs it targeted to a particular area, and so Claude, the agent, has gone and fixed a lot of the things that were it was directed at, but it hasn't fixed the things that it didn't know about. And so there we go, we've got some errors that are actually reproducible there. So I can stop that. I'll do a quick demonstration on how this works, because it's really, well, I think it's actually quite fun. But anyway, when I run make tests, we get some errors. Please look into these. There we go. I could have just said run tests, make test equal input, and it would probably have done the same thing because it knows pretty much what I want it to do now. So now it's starting to run it. It's found the type errors. It'll just run that to completion, and then it will go and try and fix them. And if it's actually working relatively quickly, I don't know how long these tests take, we may actually get to see it do some little bits. I'm not going to spend a lot of time looking at this, but it's useful to have additional pair of eyes on it, because most of this has been mechanical. It's been a case of replacing all the strings that have been handled as strings with byte sequences, replacing meta class uses with the Python 3 version of that, changing how integer division works and manipulating floats in different ways. That's basically all it's been. And at the end of the day, it's been a wonderful godsend that I've got so much testing in here, because I can just tell Claude to go and look at the tests and see what went wrong, and it can see that and go, oh, that's what's wrong, and then try and fix it, and then run the tests and see whether the test is fixed. And if the test is fixed, all is good. If it's not fixed, then obviously there's problems. But that's what I've been doing, and a lot of it's just, as I say, leave it running in the background. I started the Python 3 conversion last night about 2 a.m. And about 3:30 I fell asleep because I have to approve a lot of different operations all the times, which is very irritating. So there we go, it spotted that there's problems, and now it's starting to think about what to do about it. Let me see a full test summary. Oh, it's going to do it all again. Oh, so that took it a few minutes, and it's going to do it again. We'll see. But I started it off, And then I was just sitting there going, yes, that's fine. Yes, that's fine. Yes, that's fine. No, don't do that. Do this because you've got on the wrong track. That sort of thing. It was mostly pretty good at it. And then once it had finished, once I got up in the morning, it had got stuck on waiting for something. I told it to keep going, and got my breakfast, got a cup of tea, again told it to keep going, and about 11 o'clock today it was like, I've finished the main migration and the basic help commands and smoke tests, invocation tests, core tests, modules, initializing and things were all converted. So now I'm trying, obviously, trying to find other tests that it can run to see what the problems are, and see where things have gone wrong. Because a lot of the time, it's not actually having that much of a problem. It's just the what's the best way of saying it? The lack of rigor in knowing the whole code base. Because it can't look at everything and go, well, yeah, this is going to be broken or whatever by that, because it doesn't know it like I do. And I haven't told it to run the full. If I run the full test suite, it's like 2 hours to run the full test suite. And what it just did then was it went, oh yeah, I'll run it. Oh, hang on, I'll do that again and search for the errors. It's like, if you captured the output the first time, you wouldn't have a problem, would you? Anyway, that's what I've been doing. So Andrew, yes, it's using Claude, the AI agent, to convert it to Python 3, which is working pretty well. I mean, so if I go back to the other window, it's running those same tests again with a different grep. So if I can actually do Python 3 pyro.py command help, there we go. Oh, it's probably going to fail, isn't it? Because I haven't loaded all the internal modules. Load internal modules. There we go. And you can see that. Oh, that one didn't work either. Oh, that's good. Well, that'll be another one to have a look at very shortly. Apparently the things aren't there. No. So I reckoned it would probably be 2 or 3 months for me to convert it over. Because I don't get huge amount of time with it, and I was trying to get a lot of other things done. So Python 2 is just fine. So that's failing, but that's the pretty print code breaking, which is probably an easy one for it to fix as well. Once it's finished with this job, I'll get to look at that one as well. Yeah, so that's pretty much it. I'm going to go and have a bit more of a rest now. I may go and grab some food, I think, and all will be good. As I say, I don't know what I'm doing next week. I haven't worked out which particular bit of things we want to have a look at. Yeah. Oh, sorry. Tired. That's from sitting up to the lake, pressing yes, I want to do that. All right. I will see you all next week. It will be on a Sunday. I've got to remember it's Saturday today and tomorrow is Sunday. And I hope people are enjoying or going to enjoy my messages about the videos about the build environment and how to do things. There's about 9 of them to come. I may create some more, but it takes about half an hour to create 5 minutes worth of video. So and I haven't. They're not very well polished. You won't see very much polish in these. Right, I've clearly run out of things to say. I'm going to let you all get on with your weekend and have a good weekend. If you want to grab me, you know where my email is and all the rest of it. Could you have at least one video using Windows? Nope, I don't have a Windows machine, so can't do anything. I'm afraid. I used to have a Windows machine at my previous job, but I don't own a Windows machine anymore, so I can't do that, I'm afraid. Sorry, not what else I can say on that. I mean, I could potentially fire up a machine in the cloud or something and try that, but that would be a whole lot of extra work as well. All right. See you all later. Have a good weekend. Bye.